All right, kids, this is it. We are learning the famous quadratic formula today. But first, a quick review of what we already know and why we need to learn this new formula. If somebody said find the x-intercepts of this function, x squared minus 2x minus 15, and the graph is shown here just for a little visual backup, hopefully you would say, that's easy, old man, we've been doing that. We plug in 0 for y, or in other words, set the equation equal to 0. And we're going to try to solve this by factoring. That's the fastest and most basic way, and now we should be factoring masters. There's no GCF. It's a trinomial that starts with x squared. So this is a nice simple unfoiling pattern. What multiplies to negative 15 but adds up to negative 2, that is negative 5 and positive 3 in no particular order. And then you set each one equal to 0 and solve. And of course you get x equals 5 and x equals negative 3. And you can see on this graph, which is drawn to scale, that seems to be just about right. That's a 10 there. So that looks perfectly halfway there. That's the 5. And right there is negative 3. Okay, so our zeros are 5 and negative 3. Great. But take a look at this graph. And this is the function that it goes with it. Y equals x squared plus 4x minus 1. You can see the y-intercept is negative 1. It's opening up. But look at these zeros, these x-intercepts. There's one there and one there, and it does not cross the x-axis at nice integer values. It's not easy to tell what they are. And so if you start solving this the same way, meaning, hey, if I want to know when does y equal 0, I'll plug 0 in for y and I'll solve. But hopefully you quickly realize that this does not factor. It starts with x squared, but if you try to unfoil it, nothing multiplies to negative 1 and adds up to 4. It'd be plus and minus 1, and obviously they don't add up to 4, and that's it. So this is a case when we need what's called the quadratic formula. And not everything factors. That's why there's this formula. And this formula actually works for any quadratic, even ones that do factor, of course. But factoring is still fastest if it factors. That's why I'm still always going to look for that. Okay, so here is the formula. It is used to solve any quadratic as long as it's equal to 0. So just like if you're trying to factor, like we say, be a hero, make sure it equals 0. And then the formula is all based off of these three values, a, b, and c, the coefficients, a, b, and c. And here's the formula. It's not something you would just come up with off the top of your head. If we learn how to complete the square later in the year, you can derive it. But here is the formula. It's a big fraction. And the x values you're looking for, the solutions to this, which we got by factoring the other equation, would always be negative b plus or minus the square root of b squared minus 4 times a times c. And it's all divided by 2 times a. So that's a pretty tough formula to memorize the first time you see it, but you'll use it a lot in math, and hopefully you'll remember it. You use it so frequently. But I actually still think of the song that my 8th grade teacher sang, because she said it every time we needed it, and I never forgot it, even though it was very annoying. But so I'm just going to pass it on to you. And here it is. It's just singing this to the tune of Pop Goes the Weasel. So yeah, get ready, kids, to hear some beautiful singing here. So here it is. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Listen to that sweet, sweet pitch there. No auto-tune necessary, no Post Malone or Drake nonsense here. And I thought actually that my teacher made that up. There was no internet back then, and she was the only teacher I knew who did it. But then I YouTubed it a few years ago, and I actually saw that a lot of people use that trick. and I saw a good video. It's only 50 seconds long, and I'm going to put a link to it if you want to listen to it. It takes 50 seconds, and it's pretty memorable. And there's a lot of other versions out there. But anyway, that's knowing the formula, because step one is knowing the formula, but now we got to use it. So it's used to solve this. We're equal to 0, so we're good. And now let's just take a quick look and identify what's A, what's B, what's C. A, B, C, remember, are the coefficients. So A is 1, B is 4, and C is -1, right? And now we're going to do that famous formula. Okay, x, the solutions we're looking for, is equal to -b, so -4, plus or minus the square root of b squared. So b is 4, b squared minus 4ac. So -4 times a, which is 1, times c, which is -1, all over 2a, so all over 2 times a. So you know the formula, you put the numbers in the right spots, but still a lot of mistakes will happen, so be careful, watch out. -4 plus or minus. My advice is to not try to do too much. Take your time and simplify this. 4 squared is 16, especially the inside of the square root. That's where all this action is going on, and all these negatives and double negatives. This is where 95% of the mistakes happen. So 4 squared is 16. -4 times 1 times -1. -4 times 1 is -4, and -4 times -1 is +4. So messing up that sign right there is actually where a lot of mistakes happen. And that really shouldn't happen, because it's a negative times positive times a negative. You should really just know that's going to become positive. All over 2 times 1, which is 2. Order of operations, simplify that inside. It's like a set of parentheses. You want to simplify the inside first. 16 plus 4 is 20, and it's all divided by 2. Okay, now here's the problem. Trying to do the square root of 20. 20 is not a perfect square. I don't know what the square root of 20 is off the top of my head. I know it's bigger than 4 and less than 5. So I'll just go get it with my calculator. And this is why you're going to get decimal answers. It's an irrational number. It's not a very nice, it's not a nice outcome to that. It's not a perfect square. So we get about 4.47. I'll use 2 decimal places. So right here we have, this is so far -4 plus or minus, and the square root of 20 became about 4.47. So I'm going to take that out and replace it with that decimal, and it's all divided by 2. Okay, just be careful here. We've seen this a little bit with some problems we've done, but this is really 2 separate answers here, the plus and the minus. So one answer is this whole equation, but with a positive, so -4 plus 4.47 all divided by 2. And the other answer is the same exact thing, but with a minus in the middle, so -4 minus that 4.47 all divided by 2. Definitely use your calculator to assist you in this if you feel like you're having a tough time, but that will give you -4 plus 4.47 will give you 0.47 all divided by 2, and 0.47 divided by 2 is 0.235, or if I round to the nearest hundredth, about 0.24. This one down here, -4 minus 4.47, again you're dividing all of this, so I always subtract the top or simplify the numerator before I divide by 2, and -8.47 divided by 2 is -4.24. So there's your 2 answers. And take a look at this graph. They should make sense with what you're looking at. That answer between 0 and 1 looks, that's about 0.24. That's the one that we got here. And the other one is between -4 and -5. That's the -4.24. And yes, I know you could go to Desmos and just graph this, and you could click on these and you'd see these decimals and they'd be already done for you. So make sure on homework you're showing all this work, because if you don't show all this work, I'm not going to give you credit, because anybody can just go to Desmos and click. I mean, you should still do it to check, but I'm not going to give you credit for just doing that. Let's just try a couple more examples though, but now it's just practice at this point. You know how to do it. If you watch this example as many times as you like, re-watch it if you're confused, or email me. Number 2, we're trying to solve this equation. Now step 1, just like if you were going to factor, it's not equal to 0. So I've got to bring everything to one side. It doesn't really matter which side. I'm going to subtract 3x squared, and when I subtract it from this side, you can only combine like terms. I'm going to add 3. So I'm just going to line it up there. And that's going to leave me with 4x squared. That minus x in the middle is still minus x, and 2 plus 3 is 5. There's the new equation you're solving, 4x squared minus x plus 5. So we're going to do the quadratic formula here. A is 4, b is -1, that unwritten coefficient is a -1, and c is the constant here of 5. So here we go, let's do it. Shout out to my 8th grade teacher, Miss Hammond. Here we go. X is equal to -b. So if b is -1, negative b will be +1. It's just the opposite of b. Plus or minus the square root of b squared minus 4ac. A is 4, c is 5, all over 2a. Gets more annoying each time you hear it, right, kids? But you'll remember it. So simplify here. 1 plus or minus the square root. Now, if you want to use your calculator to simplify these little steps on the inside, that's fine. Just use parentheses, but you really don't need to if you want a little practice here. -1 squared is 1. -4 times 5. First of all, that's going to be a negative, because negative times positive is negative. 4 times 4 is 16. 16 times 5 is 80. All divided by 2 times 4, which is 8. Simplify that inside. 1 plus or minus the square root of 1 minus 80 is -79. And hopefully you see something is up here, because if you try to do the square root of a negative number, we've talked about that a little bit before, but that's what we call a non-real answer. It's what they call an imaginary answer, and you'll learn more about that in Algebra 2. But at least right now, you just need to know that does not exist. That's not a real number. You can't take the square root of a negative number. So all you would have to say here is no real solution. If you just make the no solution symbol, I'm fine with that. And here's the graph, just so you get a visual of what you're looking at in this sort of scenario, because it does happen. All that means is if you graph this, now here was the equation we were trying to solve. So that's the graph I'm looking at. If I graph this parabola, the one I'm trying to find equals 0, and you can double check if you don't believe it, 4x squared minus x plus 5, you take a look at that. When does that equal 0? When does that hit the x-axis? It never does, and that's what you're looking at here. That's what the formula is telling you. This graph will never equal 0, so it's got no real solution. And so it is possible to get those things. If you get that, it doesn't mean you've done anything wrong necessarily. You might want to look at the graph and see, hey, it doesn't cross the x-axis. No solution. Beautiful. And one more, here we go, just for fun. But now hopefully you're getting the hang of it a little bit. Another quadratic, not equal to 0, so bring everything to one side. So I'm going to subtract 4x. And And now I'll have 3x squared plus 5x minus 7 equals 0. Okay. X is equal to, this is your A, this is your B, this is your C. X is equal to negative b, so negative 5, plus or minus the square root of b squared minus 4ac, negative 4 times 3 times negative 7, all over 2a. And ready to simplify. Notice that regardless if b is positive or negative, when you square it on the inside, that part's always going to be positive. So just make sure you don't mess that part up. You know, in the last part, b was negative, but still when you squared it, you got positive 1 here. So just use your head. Sometimes people are always using their calculators and they don't use parentheses properly, and or if they do it in their head, they see negative 1 and they get negative 1 here. So just be careful with that. Simplifying this inside, 5 squared is 25. Negative 4 times positive 3 times negative 7. Negative times positive times negative is positive. 4 times 3 is 12. 12 times 7 is 84. Or use your calculator. 2 times 3 is 6. Add the inside there. Negative 5 plus or minus the square root of 25 plus 84 is 109. Divided by 6. 109 is not a perfect square. It's going to be an irrational answer here. So square root of 109, let's get a decimal approximation for that. We get about 10.44. Seems about right. It's a little bit bigger than 100, so our answer should be a little bit bigger than 10. Negative 5 plus or minus about, like we said, taking out that square root of 109 and replacing it with its decimal value, which is approximately 10.44. And we're dividing that all by 6. So here we go again, like we did in the first example. That's really two separate answers. It's negative 5 plus 10.44, all divided by 6. And it's negative 5 minus 10.44, all divided by 6. 10.44 minus 5 is 5.44, all divided by 6. And that is going to give you about 0.91 if you round to the nearest hundredth. Negative 5 minus 10.44 is negative 15.44, all divided by 6. And negative 15.44 divided by 6 is about negative 2.57. So here are my two answers, and if you want to check this out on Desmos to see it, I'll just tell you, here's what you're going to be looking at. You would graph this right here, the equation after you made it equal to 0. You would graph that parabola, and here's what I would know about it just by looking at the equation. It's opening up because A is positive. If you wanted to find its vertex, you could. But I know that it's going to cross the x-axis at negative 2.57 and positive 0.91. It'll have a y-intercept of negative 7 if you like. But it's going to cross the x-axis at about 0.91 and at about negative 2.57. Those are the answers we just found, and that's the ultimate thing to remember with this, is that's what you're finding. You're finding these zeros. And there you go. Any questions, hit me up with some email, but try the homework. Check with Desmos. That's check, not do. And let me know if you got any questions. Take it easy, kids.